Hello and welcome to another coding challenge video. Today, as I announced last week, we will see the solution to the last coding challenge I set you. Namely, given any word in the English language, use a piece of code to find all possible words which can be formed by combining the letter of the original word. I gave you as an example Python, which I hope you were all able to find the words for. Of course, we will use the word Python as our example for today, but first and foremost, we must write our code. So let's go ahead and import a few libraries first. For the first, we will say import enchant, which is actually the PyEnchant library, and what this allows us to do is find the definitions of the words we find within the English dictionary. Secondly, we will also say from PyDictionary import PyDictionary. This is also another library which allows us to find whether a word is or isn't within the English dictionary. Then we say import ITtools as ITT. Then we can say from TQDM import TQDM, and this is also another library which we've never seen before, and this allows us to create small progress bars which are very useful within a long piece of code to understand at what point we're at with the calculations. Now, having imported the modules, we will go ahead and write first and foremost that dictionary is equal to PyDictionary, spelled like this. This will be the dictionary which allows us to find the meaning to each of the words we find. We of course, as we said before, need a second dictionary, at least in the way I've implemented the code, which allows us to discriminate whether a word is or isn't a valid English word. We can do this by writing d equals enchant dot dict, and we will say n underscore GB. What this means is that the language we will be using within our dictionary will be British English. Then we can go ahead and actually implement our code, and we can say that word is equal to Python, and that our minimum length is equal to 4, which means that the words we find will have to have a minimum length of 4 letters. Of course, you could also set this to 2, 1, 3 letters, 5, however many you wish. The way I used to play this game when I was at school was having a minimum of 4 letters. So this is a small memory from my childhood which I wish to include in my code. Then we will create an empty list called valid underscore words, and that will be an empty list. Then we will say all underscore perms, short for permutations, will also be an empty list. And then we will create a code which I acknowledge is not exactly the most efficient. However, it is the most thorough, because what it will do is it will generate all possible permutations of all possible lengths of characters taken from our word in order to generate all combinations of letters possible. What this means is our code will for sure generate all possible combinations which our word will allow. However, not all these combinations will be valid English words. So we will have a first iteration which generates all our combinations, and then a second iteration which determines whether all those combinations of letters, which to start with are absolutely random, are in fact valid English words. So we will start with the first iteration and say for I in TQDM, we say range min underscore length to len of word plus 1. and then we can say desk, short for description, is equal to generating words. This should also be a comma. And then we can say perms equals ITT dot permutations of word, comma, I. And then we can say all perms dot append perms. Or better still, because we want to concatenate this, we should actually say all perms plus equals perms. Now, I don't know how many of you caught my mistake before I noticed it, but please, if you did, make sure to leave a comment below explaining why what I did before was wrong, and instead we should add the plus equal sign. Now that we've generated all our permutations, we have the second iteration, which will take all our permutations and verify whether they form genuine English words. For this we can say for p in, again, tqdm set of all perms, comma, desk equals validating words. And then we can say word equals empty string dot join p, and then if d dot check word, and remember that d is our dictionary which we defined in line 8, then we can say that valid words dot append word. Then finally we can say that result equals set of valid words. And we can say print just an empty string, and then print an f string of containing len of results, and then we say words were found, and then we can add an empty line at the end. Now, before we go ahead and use the second dictionary we defined at the beginning to write out the meaning of each of the words we found, let's just write a simple print results statement, and with that we can now print out the solutions directly from our code. We can of course do this as usual by running the F5 key, and you can see that in no time we were able to find 7 words, well technically 6 if you exclude Python from the beginning, and these are typo, hypo, fot, pony, fon, and Tony. Now understandably, not all of these words may be commonly used. However, as long as they're contained within the English dictionary, they're valid. So, in order for us to understand what these words mean, we get to the second part of our code, which is finding the meaning of the words we've just generated. We can do this in our code by writing f equals open results.txt, so a text file, as write, and then saying f.write an f string saying results for, and then we have our original word, which in this case will be Python, and then in brackets we will say len results solutions found, and you will see how all of this pans out in a second. And then at the end of it we'll add 3 additional lines. Then we can say for R in, again, TQDM. Then we can say results. And description this time will be recording solutions. And then we can say try, because not in all cases will we be able to find a solution or a meaning to some of these words, because some of them are indeed a bit archaic and so difficult to find. And we can say try, then mean will be dictionary dot meaning of R, which is our result. And we can say that disable errors equals true. This is just to avoid unwanted feedback from the dictionary. And then we say if mean is different to none, then f dot write another f string that says R, and then mean, and then we can add again 2 extra lines at the end. Then we can say else f dot write another f string that says R, and then we can add a second string that says no definition available. And again we can add 2 extra lines. Also we have again our try and except statement, for which we can copy the line we just wrote above. So if there's some kind of error, we'll say that it has no available definition. Finally we can say f dot close, because of course we need to close our file. Now we can again run our code by pressing the F5 key, and you can see in the bottom right hand corner that we are slowly recording the solutions to our text file. And there you have it. We can now open the file, and you can see that we have our list of words which we found, with next to each one the definition from the dictionary of those words. Now I hope you enjoyed today's episode, in which we saw how to write out a piece of code which basically does 3 things. It takes a word and finds all possible combinations of letters from that word in random format. Second step is it discriminates which group of letters form valid English words from the ones which don't. Last but not least, for each of the valid English words that we've identified, it will write them out within a text file next to their respective definitions. Now make sure to check in next week, in which I will show you how to implement all of this within a tkinter GUI. I look forward to seeing you then, and as usual, don't forget to like, share and subscribe. Until next time, I wish you a pleasant week, and as always, happy coding!